Hi, in this lecture I will be discussing about the losses in the power MOSFETs, and for that I have to tell you some formulas over here. So firstly we have to see the formula of the power loss during the on state of the power MOSFET, and it is involving the output current, which is the drain current square multiplied by the resistance from the drain to source terminal, and then the duty cycle, which is turn on time divided by the total time period of operation of the device. And then we have the off state power loss, which is involving the output voltage, which is VDS, which is the drain to source voltage, and then this is the leakage current from the drain to source. So multiplying it by the T off over, which is the turn off time divided by the total time period of the device. Similarly, we have the switching on energy loss can be calculated by the output voltage maximum value multiplied by the output current multiplied by the switching on time divided by 6, and then we have the switching off energy loss multiplying the, which can be calculated by multiplying the maximum value of the output voltage by the drain output current, which is the drain current, and then the switching off time, which is TF divided by 6. And then we have the total switching time, which can be calculated by summing the value of the energy loss during the on state and the off state, multiplying this whole expression by the frequency of operation of the device, and then we are able to putting that value over here, and the P on power loss and P off power loss, we are taking the summation of all these three values to calculate the total power loss of the power MOSFET. So we have to use these formulas in these numericals, and the first one is giving us a description of this figure, that its supply power is 120 volt, its load resistance is 10 ohm, its switching on time is 1.5 microsecond, its drain to source resistance is zero point 0.1 ohm, its duty cycle, which is equal to zero point 0.6, and its frequency of operation of the device of this power MOSFET is 25 kilohertz. We are able to calculate the power loss in the on state as well as the power loss during the turn on interval. So we have to calculate these two values over here, and we are doing what over here. Firstly, we are to calculate the output current, which can be calculated by the supply voltage value divided by the summation of these two resistances, which is the drain to source resistance and the load resistance, which are both values given to us, and we can put these values of the RL as well as the RDS on, and we are able to calculate the output current, which is going from here to there. And then we have frequency of operation, we taking its reciprocal, calculating the value of time period over here, and we have to calculate the T on time, which is, we know the duty cycle is equal to T on divided by total time period, which is calculated over here. So putting the value of time period and the duty cycle already, which is its value is given over here, you can see its value is 0.6 over here, and we are able to calculate the T on time. And now is we have to firstly calculate the energy loss during the on state, and after that we will calculate the power loss during the on state. So for the energy loss during the on state, we have to put the value of output current, which is the drain current over here. As you can see, we have to put the value of RDS on and the T on time, putting all these values to calculate the on state energy loss, and then multiplying that on state energy loss with frequency of operation of the device, which is already given to us over here, which is 25 kilohertz. We are able to calculate the on state power loss over here, which is 8.6 watt. And then after that we have to calculate it as well over here. You can see that we have to calculate the switching on power loss, which is being demanded over here in the part B. So for that we have done what? we are over here calculating the switching on energy loss, which can be calculated by this expression, where we have you already know the formula, which is in advance I have told you, which is this formula. So we have put these values which are given over here: the output current, the output voltage, and the turn on time. So we have the value of the turn on time, which is already given over here. We are putting this value, we are putting the value of the output current or the output voltage, and then we can divide it by 6 over here. So we are to calculate the value of energy loss during the on state, and after that we multiply this expression by the frequency of operation of the device to calculate the power loss during the switching on state. So this is this power. In the second numerical, we have to do what is that in this numerical we have the power MOSFET, we have the leakage current value given over here, and we have the resistance between the drain to source, which is this zero point 0.3 ohm, and we have the duty cycle given to us. We have the output current value, which is the drain current over here. We have the output voltage value given over here, and then we have the switching on and switching off time, which are also given to us, and we have also the frequency of operation. We are to calculate the total power loss, and for doing that we have to calculate the power loss during the on state, the off state, and the switching on and the switching off. We have to aggregate all these values to calculate the total power loss. So here we have the frequency of operation, we reciprocate it, we do the reciprocal, we have calculated over here the total time period value, as we already know that the time period value is equal to T on plus T off, and we have the duty cycle, which is 50%, so the T on time will be equal to T off time, and it will be this divided by 2, and this is equal to both of these two times. And then we have the formula of the P on power loss. We have put all the known values over here, and for the P off we put all the known values over here. For the switching on time and the switching off time, we put all these known values to calculate their relevant values, and then summing all those values to calculate the total power loss. And similarly we are repeating this whole the previous example for the case of the switching frequency, which is 100 kilohertz instead of the 40 kilohertz. Thank you very much.